All right, this is the quick notes version for the rest of chlorinization and some of the stuff we've already covered. Disinfection is the process designed to kill or inactivate most organisms in wastewater, including essentially all pathogenic organisms. Pathogenic organisms consist of bacteria, viruses, and cysts that can cause disease in a host. Three physical processes used in wastewater treatment that are useful in removing some of the microorganisms: screening, grit, and primary sedimentation. Those are all processes we've already covered. The most commonly used disinfection process for wastewater treatment is chlorinization. Chlorine, in its various forms, are powerful oxidants that will kill or inactivate most, most pathogenic organisms that are harmful to human and animal life. The typical forms of chlorine used in wastewater treatment are elemental chlorine, hyperchlorite, and chlorine dioxide. To calculate your chlorine dosage, if it is desired to have a chlorine residual of 0.5 milligrams and the chlorine demand is 6, well, for your chlorine dosage, you take the chlorine demand plus the chlorine residual. So you take the 6 milligrams and the 0.5 milligrams, and your chlorine dosage should be 6.5 milligrams per liter. Baffing is used in chlorine contact chambers to aid in mixing and prevent short circuiting. Chlorine is widely used as disinfectant in wastewater treatment, but it can also be used to control the odor, reduce the biological oxygen demand, or BOD, control foaming, and aid in sludge thickening. Okay. Elemental chlorine is normally provided in liquid form and delivered in 150-pound cylinders and 1-ton canisters. Very large plants may have it delivered in railroad tank cars. Sodium hyperchlorite is available in concentrations of 12.5% and 15% in the general form of hyperchlorite used in most wastewater treatment plants. It's also known as bleach. Calcium hyperchlorite is also known as HTH or high test hyperchlorite. Generally not used at wastewater treatment plants due to its high cost and high cost and sludge forming characteristics and its explosive nature. But it is available in granules, pellets, and powders, and contains a chlorine concentration of 65 to 70%, but it's commonly used in swimming pools. Chlorine dioxide is most beneficial when pH levels are above 8.5. It's relatively unstable and is manufactured at its point of use and introduced into the flow stream shortly thereafter. Do you think you might save chemical costs by optimizing dosage? That depends on the size of the plant. The smaller the plant, the less likely it is that you would recoup the cost of the compound loop control system. Manual control is the most commonly used mode of control in a chlorine feed system. By using a chlorine control nomograph like the one in this workbook, An operator can determine the setting of the chlorinator in units of pounds per day. Measurement of chlorine residual at wastewater plants can be determined by the use of ORP, ampermetric titration, DPD, tetrametric, and lotometric. Chlorine is hazardous when combined with moisture, including body moisture. It becomes extremely acidic and corrosive. Remember that scene in Fight Club where he, like, kisses the back of the hand and then he pours that powdered bleach on top of it, and it basically scars him for life because it became corrosive? Basically like that. Only they used lye instead of powdered bleach, but same effect. Any facility that uses chlorine should have a written safety program that is well documented and distributed to all operators. Chlorine concentration of 0.1% or 1,000 parts per million in the air may be fatal after only a few breaths. The immediate dangerous to life and health concentrations, or IDLH, immediate dangerous to life and health concentrations, is about 10 parts per million. It's not very much. Facilities that store more than 2,500 pounds of chlorine must also have a risk management plan on hand. Chlorine cylinders come in sizes to hold 100 and 150 pounds of chlorine. The cylinders have a shut-off valve, a protective cap, a fusible plug that is designed to fail and leak chlorine to the atmosphere if the temperature rises to the ranges of 158 to 165 degrees Fahrenheit. Ton containers of chlorine should be stored on their side with the two valves in the 6 and 12 o'clock positions to assure that one valve will release chlorine gas and the other valve will release liquid chlorine. One releasing gas will always be on top. Okay, if you detect a leak in the gas cylinder, position the cylinder so that the leak is on the top to release gaseous chlorine rather than liquid chlorine. Ton containers should be secured with chocks to prevent movement after being set in place. An alternative would be to place them on trunnions, which would also allow them to be rotated more readily and set to their proper position. Only trained personnel should respond to a chlorine leak. All others should leave the area until conditions are once again safe. The largest container that is used to transport chlorine is a railroad tank car. Chlorine leaks may be detected by several means. One method for testing joints or potential points of leakage is an ammonia solution. The reaction with chlorine will produce a white smoke as a visible indicator to the presence of chlorine. Kind of like the same you would do for a tire with an air leak. You put soapy water over it and it'll bubble up. Only instead of looking for bubbles, it's going to be white smoke. Okay. The chlorine residual is too high in the plant effluent. The probable cause might be that the organic strength of the wastewater influent has decreased. The flow through the treatment plant has changed. The test equipment used to check the chlorine residual needs to be calibrated. Low chlorine gas pressure at the chlorinator is suspected to be due to the depleted chlorine container. The best course of action would be to switch to a full chlorine container. A safety concern with the use of sodium chlorite in wastewater facility is that it is combustible in the presence of organic compounds. Day tanks are designed to hold what amount of chemical compounds? 1 day. Yeah, that's why they're called day tanks, because it's 1 day. Five major components to a chlorine feed system are cylinders, manual isolation valves, regulator valves, an automatic switchover system, pressure gauges, expansion tanks, injectors, piping systems, and evaporators. A detailed maintenance program should be developed and performed on a routine basis. This should include verification that the equipment is operating without leaks, the scales are functioning properly, adequate chlorine supply is available, and that the valves operate properly. Pressures are within proper range upstream and downstream of regulators. And pressures are within proper range at injector. Alright. The effluent from wastewater treatment plant may need dechlorinization after disinfection because of harmful effects the chlorine residual may have on fish, wildlife, and even human health. Common methods of dechlorination include detention ponds, aeration, sunlight, activated carbon, and the addition of sulfur compounds. 1 pound of sulfur dioxide will neutralize 1 pound of chlorine. It's a 1-to-1 ratio for to be neutralized. Sulfur dioxide is often used to dechlorinate water effluent. However, like chlorine, it is very toxic and must be handled with great care. The reasons that we would have an alternative to chlorinization is safety, health, and environment. Because chlorine is dangerous to handle. It's difficult to regulate. And the byproducts have adverse health effects. And then you wouldn't also need dechlorinization. What are the downsides to UV radiation? Unlike chlorine, where the residual measurement assumes a level of disinfection, routine bacteriological testing of plant effluent must be performed to assure that the system is operating satisfactorily. Also, UV leaves no residual, so there is no protection from the recontamination. The cost of equipment in operation are somewhat more expensive than the chlorinization system. However, a total system analysis must be performed that includes the cost of safety issues related to chlorine and the reduced size of contact basin that UV allows for. What problems could you experience with UV systems? UV lamps have limited life and will experience a reduced output as time goes on. This in turn will result in a reduction of pathogen inactivation if the systems were not properly sized. UV sleeves are subject to fouling from materials in the flow stream with accompanying dose accompanying dose reductions. UV systems are subject to fouling of the quartz sleeve due to the crystallization of dissolved solids on the surface of the sleeve, and thereby reducing transmission of light into the flow stream and the effectiveness of the system. UV sleeves are subject to discoloration, known as solarization, resulting in the reduced capacity of the lamp to transmit light to the flow stream, reducing the effectiveness. UV sleeves are more prone to solarization when used in medium pressure and high intensity systems. How can you control UV? UV may be controlled by turning on and off selected sections of the UV train and thereby increase or decrease the dosage of UV radiation applied to the flow stream. UV may be controlled by increasing or decreasing the power to a UV train, resulting in increased or decreased levels of radiation emitting from the lamps. On-off or variable lamp output can be controlled using signals from the plant flow meter. Flow pacing. On-off variable lamps output can be controlled using signals from UV intensity sensors and plant flow meters. Dose pacing. Dose pacing accounts for lamp age, condition of quartz sleeve, and the water quality. However, with greater frequency of on-off cycles, the useful life of the lamps will be shorter. UV light used to disinfect or inactivate pathogens have a wavelength of 250 nm. Three typical UV lamp configurations are closed vessel lamp arrangement, vertical and perpendicular to flow lamp arrangement, horizontal and parallel to flow lamp arrangement. UV light is harmful to the eyes and skin. Wear your PPE, people. Low pressure, low intensity UV lamps, often used in wastewater systems with a flow of less than 0.5 million gallons per day. So less than 500,000 gallons per day. In typical UV disinfection systems, replacement of UV lamps should occur more often than a replacement of the lamp ballasts. So that means changing your bulbs before you change the fixture. Flow or dose pacing are means of UV control.